Hi guys, welcome to lesson 8 of Fusion. Today's session is going to be a little bit short because of the topic. Now, if you guys remember, we talked about the top tabs and we're still following these top tabs. However, some of these can be considered a little bit advanced. So for now, we're skipping the mesh. That's an advanced topic, as you guys need to learn more about polygons. But sheet metal is an important topic that we're going to talk about today. And the one that's left is plastics. Now, the plastics isn't that unique, actually, because you only have 3 items in plastics that you need to learn about. These 3: the boss, the snap fit, and the lip, which you guys can also do with the extrude function. It only makes life a little bit easier, but there's nothing special about these. But the sheet metal is a little bit different, and there are some things you guys need to learn about. And we're going to talk about these. Now, I'm starting with a sketch, as usual. And there are 2 main ways to create a sheet metal. Now, we call it sheet metal, but you can also do cardboard designs or paper designs with this. And many people do. You can find many examples online. But it's actually created to do metal bending pieces. Now, like I said, we start with a sketch. I'm going to draw on the top one, and I'm going to show you the first method first. I'm going to create a rectangle, and I'm going to give it dimensions, 40 by 40. Click OK. Now, usually what we do in solid modeling is we create an extrusion or some kind of other solid, and in surface we create a patch or something else. But in sheet metal, we start with what's called a flange. Okay, so what we do is we click flange, we click on our sketch, and then you can see a small opening on the right side, as always, and you can see that my profile is selected. Okay, that's my profile, the square that I drew. Okay, now it gives us a couple of options. The first one is the side. You can have it on the top, as you can see in the preview. It's extruding the flange towards the top, or you can have it on the bottom, or you can have it in the middle. Okay, now this usually depends on what else you have modeled on the screen, but if you're starting, it doesn't matter. I'm going to click side 1. Of course, I'm doing a new body because I don't have anything else. Now, the one that's left, the last one, is kind of important because here you're selecting your material and your thickness. Okay, now for this example, I'm going to do a steel piece, which is 2 millimeters in thickness. Okay, then I'm going to select OK. Now you can see that the icon in my history is a flange icon. Now this flange icon gives me a couple of abilities. And the first one is I can continue creating flange items on this item. And the way I do that is I click the flange icon, and then I can click any edge on this piece to create an automatic flange. Okay, this is what the sheet metal enables us to do, which the other solid modeling objects features don't allow us to do. And I can select the length of this flange and the angle. Okay, now as you can see, as I bend the angle, the inner radius and the outside radius adapts, okay, to what I'm doing. This is important because this is how sheet metal works in real life as well. Now, the things that I can control on the screen with the arrow and the circular icon are the same things that I have on the side. But before we get to these, I'm going to show you another method to create a flange. Okay, I'm going to cancel this, and I'm going to do another sketch. Okay, and I'm going to do it on the front plane this time. Okay, I'm going to pick line, and I'm going to draw a line from the center. Okay, and I'm going to say OK. I'm going to turn this line into a construction, so this will be my baseline. So I know the object that I created before is on the same plane. Then I'm going to select a regular line, and I'm going to draw that line on top. Okay, and that's it. That's how I'm going to start my flange. Then I'm going to select flange. I'm going to select this, not the construction, but the one on top. And the way I can do that is if you can't select it with your mouse directly, you can come over the line, keep pressing your left mouse button, and then select it. Now, as you can see, the flange tab on the right hand side shows profile 1. Okay. What I can do is I can drag this line, okay, to the size I want. All right. And the dragging this arrow is the same as putting in a distance, okay. And I can still do side 1, side 2, okay. I can drag it just like a regular extrusion. I can do 2 sides with this. I can say symmetric, so I can go both sides. I can do one side. I could do on top, on bottom, just like the other one, okay? And I can do a bend override, which we're going to talk about in the next section when we get into the second flange. But this is another method to create your base flange, where everything starts, okay? So you can either do a contour drawing, just like the one on the top with a square, or you can draw a line, then create your first flange this way, okay? Okay. So what happens if I draw something that has a curve in it? Now, let's try it. Instead of doing this straight line, I'm going to add a tangent arc to this, okay? I'm going to add a tangent arc. I can see the tangency icon there, okay? And I'm going to say finish sketch. Then I'm going to go and edit my flange, and I'm going to say add this profile to it, okay? As you can see, the 2mm sheet metal rule that I applied, okay, is also applied for this. You can see the rule right here on the left-hand tree. It says rule sheet steel 2mm, okay? And I can say okay. Now, this is also a sheet metal piece. So you can start with a bent piece as well. Okay. Now I'm going to get rid of this example so we can concentrate on our first flange. Now, we talked about adding a flange, and I can click any edge to add a flange by dragging the arrow. Now, we do have some options on the right-hand side that we need to talk about. And the first one is this edge 1, which is the edge that I selected, and this full edge, okay? Now, the full edge has some options when you click on it. You can go symmetric, which means you don't have to use the whole edge as another flange. You can make it shorter, okay? So this adapts as you pull. It adapts to sheet metal machinery understanding and creates these indents. You can see these 2 indents, okay? Now that's the first wing. Now the second one is 2 sides, which means you can control both sides independently. You can make one side shorter and one side longer, like that, okay? You can go this way as well, okay? And the last one is 2 offsets. Now, the offsets are used when you have something else on the side, which you can offset according to that. Or you can input dimensions in the offset when you go towards the inner side, which means the distance between the edge of the flange to the edge of the original material, okay? So I can say 13 millimeters on this side and 13 millimeters on this side, or let's say 2 millimeters on this side, okay? So for this example, I'm going to say full edge, okay? Now, the next thing, as you know, the flange that we selected, you can select multiple edges, okay? You can select multiple edges by hitting Control, or you can add it here by clicking the plus sign. Okay, you can say these 2 edges. Okay, so Fusion creates a flange on both of these edges with the same dimensions. But let's concentrate on a single flange. You can change the height, which is the same as pulling this arrow. You can change the angle, which is the same as rotating this circular icon. Then you have some important decisions. Now, the height datum. Now, these icons are pretty good at explaining what is going on. Now, currently, this 19 millimeters of height that I have is from the top edge, okay, the top edge of this flange to the bottom face of this starting square, okay? Now I can change that. I can say inner faces, okay? Now it's from the inside of this face to the top of this face, or I can say tangent to bend, which is now considering the tangency. Now at a 90-degree angle, that doesn't make much difference, but when you go to a more drastic angle, the tangency has increased. So if we were to draw a perpendicular to this tangency, and let's do that so I can explain to you guys. Okay, let's draw a sketch and let's project these faces, okay? And let's draw a tangency. Okay, like that. Let's make it tangent, and let's make sure that this is perpendicular to this. Okay, now we know it's perpendicular. Now this is the tangency. So if we were to measure from here to here, you will see it's 19 millimeters. Okay, now this tangency changes. Okay, let me move my sketch back. Or I can't move it because I drew it on the tangency, but when I change it, let's change it to something like that, which is 100 degrees, okay? Now you can see the tangency has moved, my sketch has adapted, okay? If I were to edit that sketch, make it longer so we can see and measure it again, okay? You can see it's 19 millimeters again, but the tangency is way down below in that arc. It's right there, okay? So that's what the tangency gives you. It's useful sometimes, especially when you're putting different models together. It's very useful. Okay, let's go back to our flange sketch. Okay, so for this example, I'm going to say outer faces. Okay, I'll make it 90 degrees. Then I have the bend position. Now the bend position is also important. It defines where this bend actually starts. And what that means is, if I take the measure tool and measure from this point to where the bend starts. You can see it's 37 millimeters, okay? And if I go back to my edit feature, if you guys remember, I drew, actually let me show it to you in case you might have missed it. Let's put a measure on this. Go back to our sketch. Okay, if you guys remember, it's a 40 millimeter by 40 millimeter square. Okay. Now, when it says 37 millimeters for this dimension, okay, I can tell that my bend is starting from the inside. And that's important because I don't have that 40 millimeter by 40 millimeter square anymore. I have a base of 40 millimeters by 37 millimeters. But what I can do is, instead of saying it inside, I can say outside, okay? And when I say outside, if I measure again, you'll see it's 39 millimeters. Okay, so why isn't it 40 millimeters? Okay, now that's the part that you need to watch out for, because Fusion is measuring the bend point from this face to this face, okay? So if I measure those two, I get 40, okay? So this face is actually where the outside is referred to. Now, I have other options as well. I can say adjacent. Then, when I say adjacent, it becomes from this point to this point. You can see now it's 40 millimeters. So I have my original square flange, and the bend is actually starting from outside of my original square flange. Okay? And then I have tangent. Now, like I said, tangency doesn't mean much when the degree is 90, but as soon as I make it as such, as you can see, the tangency, because it's at the bend position, the bend isn't moving. Okay, you can see that the inside radius of my bend isn't changing. Okay, but what's happening is the newly created flange is getting shorter as I bend it. Okay, now tangency is important when you want to make sure that this fits somewhere. If you know that this is going to fit somewhere and you don't want to change the dimension of the base piece, you can select tangency. As long as your bend isn't 90 degrees, okay? Now, as you can see, when you select tangency, you can't make it larger, okay? Well, in terms of angle, you can increase the angle number, but you can't open it towards the outside. If you click inside, then you can. Okay? But on the inside, if you select inside or outside, your band will move. Okay? So you have to watch out for that. Of course, you can flip the direction of your bend, even though you select the top edge. If you still want to bend it towards the other side, you can say flip. Then we have what we call override rules. Now, when you override rules, Fusion gives you the ability to change some stuff. I'm going to show you that using the symmetric. And bring this back to 90. Okay. Now, we selected symmetric. We're gonna make it something like that. so you guys can see the override rules. Then I'm going to select override rules. Now the first one is bend override. Now this option enables you to change the inside bend radius. Okay, so you can make it, let's say, 4 millimeters to have a slower bend, or you can make it 0.5 to have a very tight bend. Okay, here's the thing that we do. We usually try to keep this constant. Usually in steel bending, what you want to have as a minimum is the inside bend radius having the same numerical input as the thickness of your material. Okay, now is it, if you're asking, is it possible to make tighter bends in thicker materials? Yes, but you will put a lot of stress into the material. Okay, and in some materials the outside of your radius will show cracks. Okay, so it's possible to do a 1 millimeter bend in a 2 millimeter thick steel, but the optimal tightness is actually 2 millimeters. Okay, but for this example we're going to continue on with 1. Okay, so that's what bend override enables. Now the second one is bend relief. Now the relief is this part, the part that is Fusion is showing us for the relief. Now you can get rid of that, but to get rid of that completely, you need to make sure that your bend is not on the outside. It has to be at least adjacent. Okay, so this bend line has to follow as a linear relationship. Okay? Then you can successfully play with the relief type. Now you have straight as an option. You have tear as an option. Okay. Then you have round. Okay. Now the tear isn't showing us anything because our bend is towards the outside, but if we were to do inside, you can see that the material is actually tearing at that point. Now this is used in some industries to make sure that this is a very tight space and you're going to weld this space, so it's not that critical. But in products, most of the time, we don't use tear, as it makes it very sloppy and very tight. So we try to use round because it usually makes better finish, but sometimes you can also use straight. Now let's take that to adjacent, so our bend moves outside. Now you have the relief width, which you can control. Okay, see the width is this way, so we're looking at it like that. This is the width. Okay, we can go down, but you can't go down all the way. Okay, you'll see an error. Okay, so you can go down to a definitive number depending on your model. This is 0.1. And you have to remember, this material is going to be cut by a machine, so the machine has to be able to cut it. Then you have the depth. Now you can go to 0 with the depth. If you want a clean bend, instead of playing with the width, you play with the depth. But that's only in adjacent. If you do it on the inside, it will not allow you to have a 0 depth in that way. Okay. It will look like a 0 depth, but you will still have the side flanges because you're moving the bend towards the inside of the material. Okay. It'll only look clean if it's adjacent, or if it's which one was it? Oh yeah, it'll only look clean if it's adjacent. Okay. Now the remnant, I have to give this something to show you the remnant. Okay. Now, let's make this 10 so you guys can see. If the number that we see here on the remnant is equal to or bigger than our offset, it will cut it. So if I go to, let's say, 7, you can see a remnant right here. This is called the remnant. But as soon as I get to 9, 10, I lose the remnant. So I can, it's clear to understand if I turn this to offsets, okay? See, 5, 6, 8, 9, 10, 11, then it starts. It starts at 11 because I have this relief width, okay? So you add that to the remnant, and as soon as I pass 11, I get a remnant. So if I increase this to, let's say, 12, it'll start at 14. You can see 13 because 12 plus 1 for the width. So after 13, I get a remnant. Okay. Now, this depends on what you're doing. We usually leave this at twice the thickness of material. Okay, so after 5, I get a remnant. Okay, so this is what these 3 do. Of course, you can play with these. You can make your depth much higher. If you're going to use these tabs for something else, like for locking into a material, you can increase this so this part goes into another material. Let's say if I move this towards the inside, I can do this. Okay. Let's say I have another sheet metal on the back side and I want this piece to go into that piece. I can finish this flange as such, then select this and pull it out as such. And even then, I can create a locking piece, something like another flange here. Okay, something like that. So this would go in and sit on another piece, for example. So this could be a small locking feature. Okay, so let's hide this sketch. Okay, something like that. So there are many options that you can play with. Okay, now let's go back to our flange. Okay, so that's the bend relief. Now, 2 bend corner. Now this, from this point on, the options only work with multiple bends on sides. What that means is I have to create a new flange on this side, for example, with these 2 edges. So I have 2 bends that meet, okay? And you can see I have this small piece, right? That's because I didn't control my overrides yet. So the first thing is the miter corners. Okay, if I uncheck this, you can see I lose that piece. So there's no mitering, there's no cleaning this edge. Now a bend such as this, which you can see in many sheet metal objects, will create a small bump on this corner, which isn't usually liked by customers because it can cut your hand and it looks like a bulge. So what you do is you miter the corners sometimes, then you weld these 2 edges to make a clean transition. Okay. Now there are other options as well. So if you say override rules and select 2 bend override, you have round, for example. This is preferred by many people as it creates a very clean meeting point. There are square, okay, tear, which looks like a unmitered edge, trim to bend. This won't work on this option. There's linear weld, which also won't work, and there's this arc weld. Now, these three don't work because of the type of the bend we have, but in some options you can also use these. As the explanations you can see below. These are usually on more advanced bend types. We're not required to do those, but these three you can use: the tear, the square, and the round. Okay. Now, round, as soon as I click round, there's this relief placement that opens up, and there's this relief size. Now, I can play with the size. I can say 4, for example, but because of my sheet metal thickness and my radius, this 4 doesn't really mean anything. I will only get something after 5, okay? This looks like a pretty tight round, so I will increase that to 6 maybe, okay? Then I have my placement. Do I want it tangent, okay, which won't work on this, and intersection? Well, I want it in intersection because my bends are 90 degrees, so tangent doesn't mean anything, okay? But if you increase your bend types to, let's say, let's make this inner face. Let's increase these bends like that, okay? Then let's say tangent, okay? Now towards the inside, we should do it towards the inside. They're hitting each other. Let's shorten them a little bit. They're still hitting each other. Something like that. Okay. Okay, the tangency doesn't seem to work on this edge. Yeah. Okay. Only intersection seems to work for this example. Let's look at square. Square only has intersection. Yeah. Okay. I need to look into how the tangency used to work because I think they changed it. Is it because of the size? No. Okay. Can't remember that one. I'll look into that one. But intersection works with the round. So that's how you do mitering corners with the 2 bend override, and the 3 bend override only works with 3 piece bends, not for this example, but if you have 3 pieces merging at a point, then you could do a 3 bend override, which is an advanced bend type. You guys are not required to learn as of yet, but these 2 you guys should definitely check out. Now I'm going to make this a little bit higher and show you some details. Now, because we bent this one towards the inside, it's eating from this, our locking edge, okay? So I'm going to change that, make sure that's towards the outside or adjacent even. So we have this. Now, this is fine for manufacturing. This can be manufactured, but if I were to use this in a product, it wouldn't look that professional because I have these huge gaps. Instead of having those gaps, I can play with this after the fact. And one of the things I can do is I can extend my edges, okay? Extend my edges as such. And I can do that by using offsets, for example, or modifying existing features, automatic, okay? I can say extend my piece, extend this piece to this plane. And the way I do that is I have to first select press and pull, then before I select the face that I want this to be offset to, I have to move it a little bit. Then I can say, okay, do that. Now you can see that this edge isn't looking good. Okay. See, what I can do is, instead of doing this flange as such, I can change this to, instead of saying trim to bend, I can say, let's say round, no, let's say tear, and do it like that. Or the tear doesn't seem to fix it. I can say trim to bend. No, that's not going to work. I can say square. Relief size 8. 8 is too big. 5. What about 4? Yeah, let's say 4. And I can do something like that. And this part can be left open. Or I can even fix that. I can say press and pull this to this point. That looks good. And I can say press and pull this to this, but not exactly. Leave a little bit of gap. And I can make a clean corner as such, or I have to do this as well. Okay. Something like that. This is the way I can make a clean corner. Of course, this is only if it's not going to be welded. If it's only going to be bent and left as such. Okay. Now that's how you can make a clean corner. Now there are other things I can do as well. Other things that I can change. Now this is a solid, so I can do anything that I can do with a solid, as creating a extrusion on this. As such, I can cut it. Okay. But the one thing that I have to watch out for is manipulating the bends in the solid modeling environment, because if I were to modify these bends without understanding how sheet metals work, I can damage the bend. Okay. And what do I mean by that? Well, let's say I want to do a cut on top of this, just like this circle. I'm going to create a sketch, and I'm going to say I want to cut this piece with a rectangle. Okay. I'm going to cut it, and I'm going to cut it to there. Okay. Something like that. Now, it's not possible to machine using sheet metal working machine and do something like this. This needs to needs to have another type of a process. Okay. What if I go all the way and past the surface? Okay, what if I do something like that? Well, this is a problem as well, because I'm still cutting the bend. I'm inside the bend. This is the bend. Okay, I'm still inside the bend. So what I have to do is I have to go through the bend. I have to make sure that I went through the bend. Okay, now this is okay. Why is the other one not okay? Well, I'll show you. I'm going to press Ctrl Z, undo, go back to this. And what I'm going to show you is why we're using sheet metal in the first place. We could have done everything that we see here with an extrusion, okay? But the reason that we're using sheet metal for this is what's called unfolding, enfolding, okay? So we have this thing called an unfold, okay? Once we click this, it's asking us for our stationary entity, the entity that we don't want to have move in any manner. And that's our starting square, okay? I'm going to select that. And as soon as I select that, because unfold all bends is selected, it's going to open up all of my bends, okay? You can see that my bends are marked with a dark green. And I'm going to select OK. And you can see the small unfold icon. Now the icon has a negative sign, a dash under it. That's because this is an intermediate process. What that means is after you do what you want to do here, you have to refold, okay? And we're going to refold after we finish what we're going to do. Now, as you can see, this is our sheet metal opened up, okay? You could do the same thing with a cardboard box, for example. Now, from the top, it looks okay. But from the bottom, we have this weird surface. Now, sheet metal parts are usually cut with a laser or a water jet or a router. Anything that cuts two-dimensionally, that can process steels, metals, can be used to make sheet metal parts. But those machines will have a hard time, especially a water jet or a laser, to make features as this. So when you input this form into the machine, it will give an error because of this part. It will not be able to process this. So that's why you have to pass the bend when you're doing a feature like this. Okay? So that's important. Now, let's do something while we open this up. Let's do a sketch on this face. And let's do a capsule. Let's do a capsule. Something like that. Finish sketch. Extrude. Cut. Okay. Now we cut it while it's open. Now we're going to refold it. Okay. Now, the nice thing Fusion gives you is you can see this bulging at these parts, right? Now, this is what will happen when you produce this piece. It's showing you the bulging, the compression, and the tension that we're seeing at this corner. It's showing you that. As you can see, we did do a capsule, so this should be perfectly tangent to each other, but you can see the tangency breaking. Okay, this will happen in the manufacturing process. Okay, so that's one of the advantages of doing your cutting when the object is flat. So this feature, it's not working for us, so let's get rid of that. So we have a metal part that we can send to be produced. Now, one thing you need to watch out for, and Fusion will not show you this, is if you create holes that are too close to the edge, too close to your bends, okay, something like this. Okay, it's not exactly touching the edge, but it's very close. Okay, and we cut our hole, so we have our hole, and it's showing a nice hole. It looks perfectly circular. And if we unfold, it doesn't seem to be changing. However, you can see these two weird faces. Okay, now this is the start of a problem, but Fusion is not going to give an error about this. You can refold your face, it seems fine. However, if you were to manufacture this, and if you had a hole as such, as close to an edge that was going to be bent, this hole will be deformed, okay? Now, let's do the same thing while the object is unfolded. So you can see it that way as well. let's find an edge. Okay, let's do it close to this edge. Let's do a sketch here. Put a circle, go towards the edge, extrude our hole. Okay, and refold. Okay, Fusion is still showing a perfect circle. And if we take our measure tool and measure it, you can get a radius, which means the circle is still a circle for Fusion. Now, this is a problem. This is where Fusion lacks the ability to show the deformation of this hole that will happen in real life. So, there are different kinds of tables that you can find on the internet. The one I use is made by a company called Vila, and I will show you that in a minute after we take a break. But Vila will give you where your deformation will start. Okay, so let's take a break for now. Be back in a second. Okay, now if you want to do sheet metal parts, or like I said, cardboard, plastics, you can use this method to make sure that you're making a part that is actually bendable and cuttable. Now, one of the features that you can use for metal parts, especially sheet steel, is you can use the online catalog information from known manufacturers, and one of them is Vila. Now, Vila, you can go to their website at vilatooling.com. You might have to sign up, which is a fast process, but they have information regarding to their tools and what you can do with those tools. Okay, now if you go into products and select their online catalog, you will get something like this. And if you scroll towards the back pages, okay, let's do it like this. Okay, they have this thing called the bending information. Okay, now let's zoom in. Okay, now here's some bending information for metric. Now, you can see there are some explanations here, which are the important parts. Now, there's this thing called B, minimum flange, okay? This minimum flange is what you can bend with these dies, okay? Now, you can use these different die types, okay? The V is the die type, okay? It's the width of that die. Okay, the S is your material thickness, which you can see on the left-hand side. Okay, for example, we're working on 2 millimeters, and if you follow this line, you have some numbers here, which are your forces in tons. Okay, and you have this thing called the minimum flange. Now, the minimum flange numbers are given on the third row. Okay, now this is the number that your flange in Fusion has to be bendable. Now, if you look at 2 millimeters and find your first number, which is 22, and go up, it says 8.6. Okay, that 8.6 is critical. Now, keep that number in mind, 8.6. Now, we're going back into Fusion. Now, what that means for us is this circle has to be 8.6 millimeters away from this bend. So if we were to edit this, edit our sketch, this is the circle sketch, okay? We have to make sure that this circle, the edge of that circle, let's put our dimension tool, let's click our edge, then let's right click, select pick circle arc tangent and select circle. Okay. This has to be 8.6 millimeters to not deform when it's being bent. Okay. So this is one critical aspect that you have to keep in mind. So that's might seem like a small detail, but it's critical. So you can use that information that you see here on the Villa catalog, for example, and many manufacturers have their own catalogs to find this information. Okay. So what you do first is you find your material thickness on the chart on the left. Then you follow your material thickness to your first available number. Go up, look at the die, 20 millimeter die, okay? Some manufacturers might not have 20, let's say they have a 24 millimeter die. Then you go down to B and look at your minimum flange distance, okay? That's where you put your circle in our example, okay? Now, of course, after you design your parts, you want to send them to be cut. What you do then is you say create flat pattern on top. So you select create flat pattern, the right hand menu opens up, you select your stationary face and say OK. If your part is fine, Fusion will create the part. If it's not fine for some reason, Fusion will give an error, as you can see, and it will not create the part. Then what you have to do is go back and correct your mistake. Now, the first thing that you can do is unfold to see where your mistake is. Now, in our example, the circles might be creating this mistake because they're too close. So what I'm going to do is I'm going to clean all the stuff that we did on the inside up to this point. I'm going to say roll history marker here, and then say delete all features after history marker. Okay. Then I'm going to say create flat pattern again. It says one already exists. Do you still want to do it? I say yeah. And here I have my create flat pattern. Okay, so one of those circles might be creating a problem, and that's fine. You can go back and look at what you did to see what the problem was. Now, what you can do here is, before you say finish flat pattern, you can export it as a DXF file, which is a very common file for 2D drawings. We say finish flat pattern, then we come back to our original object. Now, this is mostly what we do with sheet metal. There is one more thing that I want to show you. It's called the bend. Now, let's say you don't want to create a flange from the edge as such, but what you want to do is you want to bend something that you already created. What you can do is you can go to one of your flanges, create a sketch on it, then draw a bend line from edge to edge, okay? Something like that. Finish your sketch, okay? Then select bend, okay? Now, this doesn't have to be edge to edge always. You can pass the edges, that's fine. But the bend asks you which side you want to keep as the stationary side. And I'm going to say keep this side as stationary. Then bend at this line, okay? So I can create a bend in this manner as well, as you can see. Now I have some options here, just like I did with inside, outside, or adjacent. I have flip. I have my degree, which is my bend angle, okay? And I have my bend relief on and off, which I can control from this, okay? So that's how I can bend with a bend line without using the flange. Now, as the last thing that I'm going to show, we have this thing that's called convert to sheet metal. Now, what I can do is, and I'll show you this on a new design, I can start by creating a sketch. Then let's say I extruded this 2 millimeters. Okay. But I haven't decided yet, or I hadn't decided yet that I wanted this to be a sheet metal. Okay. What I can do is, if my radiuses and if my flat pieces are fine, and I'm going to do that as an example in the solid modeling environment. I'm going to say, let's project this side because I'm going to use it. And let's make a tangent curve from here to here. Let's offset this curve 2 millimeters, okay, and connect these two, okay. Then let's create a rectangle, a 3-point rectangle from this edge to something like that, okay. Then let's extrude these two, and instead of a new body right there, let's select join and extrude them to here. Okay, so I have something like this. It's in solid modeling environment, as you guys see, so this is not a sheet metal, and you can see there are no sheet metal rules on the left hand side, but I decided I want to convert this into a sheet metal. As long as my thicknesses are fine, they're not changing, I can go into sheet metal. I can say convert to sheet metal and select my object, okay? As soon as I click my object, Fusion recognizes that this is a 2 millimeter thick piece. So it's giving me options about that. And it says this rule is fine for this, okay? You can either select stainless or steel, because those are the only 2 millimeter options that you have. But I'm going to select steel, and I'm going to say OK. So as soon as I do that, I get my rule, which says convert, which means it's coming from a solid. And I have this small icon. Okay. As from this point on, I can act like this is a sheet metal, and it will act like a sheet metal. So you don't have to start with a flange. You can start with a solid as long as you have a controlled thickness of material all the way through. Okay? So that's one way. That's another way. And that's about it. The rest of the stuff we're not going to use that much. Sometimes what you might want to do is you might want to change your rule, okay? You might want to say, instead of this being a 2 millimeter, you might want to turn it into 1.2, okay? You might want to say, I want this to be 1.2, okay? What you can do then is you can go to your sheet metal rule, okay? From your library, make sure that it is available, okay, and convert it. Now this is coming from a solid, so it's problematic, but if you go into our original one, you can say, because it started with a flange, you can say I want to change this to 1.2 millimeters. Say OK, and as soon as you say OK, you can see that it got thinner. It changed everything and adapted everything that it did with sheet metal to your new rule. I can say, let's say, what else do we have? We have 1 millimeter, for example. Let's say OK. So it got thinner. However, it won't change the stuff that you did with press and pull. You can see that this edge is on the outside now, so you have to manually modify those. Something like that. Okay. So that's how you can also edit your objects after the fact as well. So that's it for sheet metal. We're going to have a in-class assignment about this as well on Wednesday. So I'll see you guys on Wednesday.